Now this is going to be a short, brief lesson on multiplying and dividing radicals. Now what we found, hopefully, when we added or subtracted with radicals, the radicals had to be the same. In other words, square root of 5 plus square root of 6 could only equal square root of 5 plus square root of 6 because the radicals were different. We could not combine them together. If we were to do square root of 3 plus square root of 3, I have one of those objects here, one of the objects there, they're the same. We end up with 2 square roots of 3. For multiplying and dividing, though, that's out the window. You can multiply radicals that have different radicands so long as the bases, the powers are the same. So here we have 3 times square root of 12 times square root of 6. I'm going to rewrite this way. 3 times the square root of 12 times 6. Now it is possible to go ahead and start factoring some of these things. In fact, we could have done it from here. 12 is 4 times 3. 6 is 2 times 3. 4 is 2 times 2. So there's a pair right there. I can't pair these up yet, but we'll get to that in just a moment. Since I have a pair, I can take a single 2 out to multiply it with the 3. But let's just go from here. Alright, so we have 3 square roots of 12 times 6. 12 times 6 is 72. Multiplication part is done. However, this is not simplified, and the instructions say simplify. That means you keep going until there's no more math that you can do. And there is some work that we can do. For example, 72 is 8 times 9. 8 is 2 times 4, and 4 is 2 times 2. 9 is 3 times 3. So what we have is 3 times the square root of 2 times 2 times 2 times 3 times 3. 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3 is 72. Now in this we have a pair of 2's and we have a pair of 3's. So each of those gets brought out as a single item. There's the original 3. That's for the 2's. That's for the 3's. And under the radical we still have a single 2. 3 times 2 is 6. Times 3 is 18. That's the answer. I realize that it looks like there are a lot of steps. However, if you know your multiplication chart, if you can do your multiplication up to 12, this becomes somewhat easier. Let's look at one that has exponents, like this one here. Alright, so let's see. I'm going to factor these somewhat as I do this. So I'm going to combine it all underneath one radical. So I have 15 n squared times 10 n to the third. Here we go again. I know that 15 is 3 times 5. I'm going to go ahead and combine my n's. N squared times n to the third. Remember, when you're multiplying variables with exponents, you add the exponents. So that's going to be n to the fifth. Now the 10. The 10 is 2 times 5. Looky here, we have a pair. We have a pair of 5s. That comes out as a single 5. And there are no more pairs. Now here's a shortcut to doing variables or anything raised to a power on the inside of a radical. This radical is a power of 2. If you divide this number by that power, 5 divided by 2 is 2 with 1 left over. So I have an n squared that's going to come out to the outside. But let's see how that happens. Okay, so we have 3 times 2 with a 5 on the outside times 1, 2, 3, 4, 5 n's. Now if I do the division, 5 divided by 2, this power divided by that power, 5 divided by 2 is 2 with 1 left over, a remainder of 1. So I should have on the outside n to the second power, and here's why. Here's one pair of n's, here's a second pair of n's, and 1 left over. 3 times 2 is 6. This cannot be reduced any farther. And we have a single n left on the inside. Bada boom, bada bing, that's it. Right below this, we can do some from the beginning, or we can spread it all out like we did right here. Remember, this is to the power of 2. 3 divided by 2. Well, 2 goes into 3 one time with 1 left over. So this turns into negative 3 n, or r rather, r. And on the inside we had 1 r left over. Now this. It's power of 2. 2 divided by 2 is 1. So this is times 6 r with 7 left over. This turns into negative 3 times 6 times this r times this r. And for the radicand, 7 r times 7. Here's a pair. So the 7 now comes to the outside. R times r is r squared. And under the radicand, a single r is left. Negative 3 times 6 is negative 18. And 7 times 18, I believe, is, well, my mind just went blank. 126. Let me check that. Negative 3 times 6 times 7. Negative 126. So the answer is negative 126 square root, negative 126 r squared, square root r. That's r squared right there. Whew, look at this ugly thing. What we going to do? Parentheses mean multiply. This is the distributive property. This times this. So 5 square roots of 3. And then this times this, plus square root 3 squared. Well, an interesting thing happens when you square a square root. When you square a square root, it makes the square root symbol disappear. So this turns out to be 5 square root 3 plus 3. Now can we go ahead and add these together? No, we can't. These are not the same objects. So this is simplified as far as you can take it. Can't go any farther. Same sort of thing works here. 2 square roots of 5 times the square root of 6. That would equal 2 square root 5 times 6. 2 square roots of 5 times 6. Plus 2 times this is 2 times 2 square roots of 5. This 2 came from here. This 2 came from here. So let's clean this up. Square root 5 times 6. Well, if we factor this out, the only thing we can do is 6 is 2 times 3, and that does not give us any sort of pair here underneath the radical. So all we can do is multiply the 5 and 6. It's 30. So 2 square roots of 30 plus, and the only thing to do here is 2 times 2 is 4 square roots of 5. There's no more that we can do. This is the final answer. Okay, so that's multiplication. Multiplying, they do not have to be the same radicand, the same value under the square root symbol. In fact, you can combine, when you're multiplying, combine the radicands under one radical or square root symbol, or whatever power it happens to be, as long as both have the same power, and then simplify. Now what about dividing? Dividing is a different beast altogether. In dividing, remember, if you have like items on top and on bottom of the fraction, you can cancel those out. For example, here we go. 15. So square root 15 is the same as square root 3 times 5. And 5 square roots of 20. Well, 20 is the same as 4 times 5. I'm going to change the form of these a little bit. Now I'm going into great detail for your understanding, not because you have to do every one of these steps. Alright, so here we go again. So on the top, another thing that you can do is you can split this up into two different radicals. You can have the square root of 3 times the square root of 5. That means on the bottom you can have 5 times the square root of 4 times the square root of 5. And look at what happened here. We have exactly the same on top and bottom. Square root 5 divided by square root 5. Those two cancel out. And here's what we're left with. Not done yet, but we're close. Okay, so that's going to equal square root 3 being divided by. Well, what is the square root of 4? The square root of 4 is 2. So on the bottom I get 5 times 2, which is 10. And this is the final answer. Now, will your calculator do these? Yes, it will do them. It will give you a decimal answer. The TI-84 calculator will not give you an answer that looks like this. It will not give you an answer with a radical in it. Not now, not ever, probably. There are some calculators out there, though, that you could type this in exactly the way that it looks here, and it will give you an answer that looks exactly the way that this one does. Casio, I believe, is one of those calculators. So, division, I did say it's a different beast. It doesn't have to be hard. It's only as hard as we want to make it. Yes, it's going to take steps, and that's the part that everybody thinks is hard, but it's not hard. The one rule of dividing with radicals is that in your final answer, you cannot have a radical on the bottom of a fraction. If this were flipped upside down and it were 10 on top and square root 3 on bottom, we wouldn't be done because we cannot leave a square root on the bottom. Let's try this one. Okay, here's what I know about 8. It's 2 times 4. So square root 2 times square root 4. And already I see something. Square root 4 is 2, so I can probably take care of that. Now 100. Okay, if I can get that to be a product of either 2 or 4, then there's something I can cancel out. Let's do 100 square root of 2 times square root of 50. Now looky there, that cancels out. Now we continue. Square root of 4 is 2. So 2 on the outside. And 50 is 2 times 25. So square root 2 times square root 25. Well, the square root of 25 is 5, because 25 equals 5 times 5. So we bring a 5 out, and now we have 2 over 5 times square root 2. Now we can't break this down any farther, but it's not finished. We are not simplified. And the reason why we're not simplified is because we ended up with a radical on bottom of the fraction. We can't have that. What we're going to do is we're going to employ a math tool that we've used many, many times before, and that is we're going to multiply by 1. And you know, if you multiply anything times 1, it does not change its value. For example, 5 times 1 equals 5. I didn't change the value of that number. X times 1 equals X. I did not change that value. Now, there are several ways or forms that you can use to multiply by 1. If I have a number being divided by itself, that equals 1. 2 divided by 2 equals 1. 700 divided by 700 equals 1. So I want to write the number 1 in a way that will help me get rid of this square root on the bottom of this fraction. How I'm going to make the number 1 is I'm going to divide the square root of 2 by the square root of 2. Square root of 2 divided by square root of 2 equals 1. So I'm only multiplying this by 1. That means its value will not change, but its appearance will. All right. Top times top, 2 times the square root of 2 equals 2 square roots of 2. It comes from the top right here. Now the bottom, 5 square root of 2 times square root of 2. Well, square root 2 times square root 2 is just the number 2. Square root 2 times square root 2 is square root 4, and the square root of 4 is 2. So this turns into 5 times 2 on the bottom, which is just 10. One more step, because we're multiplying by 2 on top outside of the radical, and we're dividing by 10 on the bottom. Both of those are factors of 2. You can use your calculator for this. Leave the square root out and do 2 divided by 10. Math, enter, 1 over 5. Because we still have other things on the top of the fraction, we don't have to write the 1. So we just simply write square root 2 over 5, and we're done. I know! Isn't that neat? Hey, looky here. Once you get the hang of these, you begin to find shortcuts that you can do right from the start. For example, we have an x here and an x there. Those went away because I could split this up as square root 15 times square root x times square root y over 3 square root 10 over square root x over square root y, square root y, square root y. Why? Because I love him. Oh, sorry. And look, that goes away, and that goes away. What do you think will happen here? Square root y times square root y means square root of y times y. This reduces to just a y on the outside. So here's where we're at now. I'm going to go ahead and factor this and this as I go along. So on the top, I'm going to have the square root of 3 times the square root of 5. And on the bottom, I've got 3, my y from right there, square root of 2 times square root of 5. And I have something else that cancels out. So now I have square root 3 over 3y square root 2. Beautiful! Except we ended up with a radical on the bottom. We need to take care of this radical. How do we do that? By multiplying by the number 1, which we will create using this right here. Square root 2 over square root 2. Okay. So on the top, we end up with square root 3 times square root 2, square root 6. And on the bottom, we end up with 3y times square root 2 times square root 2. 2 times 2 is 4. The square root of 4 is just the number 2. So this is 3y times 2, which is 6y. Can't go any farther. That's it. We are done. Yeah. Can you believe it? Oh, man. We were all good till we got here. What do we have here? We have 3n times n plus the square root of 2n times n over square root 10n. Ugly. Well, here's what I'm going to do. I'm going to start out by multiplying the top and bottom by 1. 10n. So here we go. 10 square root 10n over square root 10n. Square root 10n times square root 10n is just 10n. So 3 times n plus square root, sorry, I've already messed that up, times square root 10n plus square root 2 times 10 times 1, 2, 3 n's over 10n. This is distributive property. It was square root 10n times this and square root 10n times this. Alright. Nothing can be simplified here. We can do a little work here. And we end up with, well, hey, 10 is 2 times 5. So I end up with a pair of 2's on the outside. And I have a pair of n's right here. So this is 2 times 2 times 5. So 2 comes to the outside. So I have 3n square roots of 10n plus 2n 5n being divided by 10n. Now I'm going to look at things that are common on top and the bottom. Right. They have to be common to all 3 terms. In other words, I have this 10 on bottom here. I can reduce with that 10 if it divides evenly into this number and this number, or they share common factors. Now 2 and 10 share common factors. That would make 1 over 5. But I don't get the same thing with the 3. 3 and 10 do not have any common factors, so I can't reduce any of the coefficients. The n's, however, I can. I've got an n here, an n here, and an n here, all on the outside of the radicals. So I can cancel a single n here, a single n here, and a single n there. Now I'm going to clean this up and we'll have our final answer. This equals 3n square roots of 10n plus 2 times 5n all over 10. No radical on the bottom, no more reducing, simplifying to do. We are done. Anyway, aren't you glad I didn't give you a worksheet to do on this? I hope at least some of this was understandable to you. Dividing with radicals, multiplying with radicals. You can do it. I know that you can do it. At least now you have some idea of what you should do and the powers that you would have in doing this. I hope everything's going well with you. Thanks. Bye.